This video was bang on brilliant stuff. I'll give it a shout out in my next video. I've forwarded it to Malcolm to check out too.
The viewers have spoken.
What an amazing documentary. Thanks for producing it.
Never seen this all tied together so well. Gonna share the heck out of it. Bravo, and thank you.
Divine Science is officially a hit.
Amazing stuff, very nicely presented. New sub who can't consume your content quick enough. Great video, dude. Keep at it, you are doing the good work.
You did a great job putting this all together. It's a great overview, goes into amazing depth at times, so it's interesting for the larger swath of people. Well played, sir.
Okay, so I didn't sleep last night because I watched this 3 times and binged the rest of the channel. You have fantastic instincts for piecing concepts together. Almost every section was something I was already familiar with in a different context, and this documentary was the thread connecting them all.
Join us on a journey into a place of hidden knowledge. A place where science is stranger than fiction.
You may begin to feel anxious or excited. High dosage administration can cause adverse reactions. This is a normal response.
Its highlights have been compressed on this recording to make their own disquieting points.
Remember that death is not the end, but only a transition.
Imagine a world where time travel is no longer confined to the realms of science fiction.
Time travel.
It's possible, sir.
Where do you come from?
I'm from the past.
Imagine being able to plant crops in the morning and then harvest those crops that very night. Or how about healing a wound with a localized time acceleration device? A device that can speed up time in a small focused area, reducing the time it takes to heal wounds. Take a moment with me to imagine this world. A world where time is no longer a constraint, but a tool. Remember Back to the Future? The flux capacitor is a fictional device from the Back to the Future movie franchise that was used to achieve time travel. According to the movies, the flux capacitor is powered by plutonium and generates the 1.21 gigawatts of electricity needed to create a temporal displacement field. Sounds like a giant load of fiction, right? The truth is actually a lot stranger than fiction. Let's explore further.
And you told me the whole story. You were standing on your toilet and you were hanging a clock and you fell and you hit your head on the sink. And that's when you came up with the idea for the flux capacitor, which is what makes time travel possible.
Hey, Scott!
Hello, everyone. I'm the Benefactor, and this is Beneficence TV, dedicated to providing you solid entertainment while keeping you informed. We are a progressive media outlet with the focus on providing thought-provoking content on forbidden knowledge regarding topics such as Marxism, plasmoids, zero-point energy, vortex-based math, and anti-gravitics. Our aim is to combat the spread of dangerous misinformation and to educate on these intriguing and unconventional areas of study while separating fact from fiction. Join us on our journey of discovery and challenge conventional thinking here on Beneficence.
Or welcome to the show. And I guess, this week's been kind of a crazy week for me anyway. Doing a huge amount of research on my power cells and finding right materials. And we were talking offline earlier about problems obtaining the graphite plates that I need to make the cells. And I could actually do a whole show on that one right there, because
you're gonna have to, as you figure it out and experiment with it, because that's literally what we're doing here and what you're doing, inventing.
Yeah.
And part of inventing is having to source the bloody materials to begin with, right?
Exactly. One thing I've actually done this week is actually developed a conductive ink. So it spreads on with a paintbrush, and you can make any surface conductive. So this product is on Amazon right now for a 50 ml bottle. It costs you $85. Okay. My product, I would be able to sell it for twice as much ink for probably a little bit less in price. So I'm going to develop this, and I'm actually going to sell it. I think I'm going to go that far and actually produce this for, my inventors that come onto my channel, and hopefully be able to drum up some sales with this conductive ink. And that conductive ink is going to actually be used in my cell. So yeah, there's a lot of applications you could do with the conductive ink. Many battery experiments. It's endless what you could do with this stuff, because you can apply it to any surface. So actually, Nathan, I kind of thought of you when I made this conductive ink. That might be something you might want to try out.
Where do you want me to put it?
Put it on one of your plates.
Discs, of course.
Put it on one of your discs and actually put pure graphite. So now you'll have a more capacitive value on your collector plate where the electrostatic charge is.
Because for the over unity device you created?
What, from you're talking to me, Phil?
Yeah. Is that the
for the power cell? Yeah, the power cell technology. But what I was thinking with Nathan, what he's doing, Townsend Brown was doing like capacitance plates. He was using paraffin wax and a whole bunch of stuff. He was actually making like an electret, and that was also helping his devices levitate in his early experiments. He was using beeswax, paraffin wax. He was using tar, aluminum foil. He was using all those, and he was making the giant discs, putting them in the vacuum chamber. And even that they're in the vacuum chamber, they were still levitating. So for it to be an ion engine is incorrect because it's in the vacuum. So obviously there was something else going on, and that's when, back in the 50s, he came to Toronto and worked out of Pearson International Airport in Malton and started Project Silverbug, which was the Avro car.
Okay.
So the front company was Avro, and DesignX was a spin-off of Avro with three British engineers, and they created the cold heat engine. So that's a whole big story. I got some of the links on my YouTube channel under the community section. Might want to check out those. It's Canada's cold heat engine. Really fascinating, really cool stuff. And
so
they succeeded.
I was going to say it would work if we go to solid state, because I can bring in the plates as a capacitor, then you get a high K value. Then it would really help. When it's open up like this, the way it is, it's not going to be as helpful
Yeah, because it's losing its charge, right?
Yeah.
So you need something to hold that electrostatic charge in. Yeah.
If I wasn't reverse engineering someone else's design, I would have already gone solid state and fixed the problem.
Right. Yeah.
Getting the
plates. But even modifying or try to modify one plate just as an experiment, just to try it out, right?
Oh yeah, I got a spare gravity flyer. I'll do it. Absolutely.
Yeah. Yeah.
I was gonna change the center to a copper on the inside with the aluminum on the outside. One of the guys that watches my channel suggested it to me so I can get a higher resonance value out of it. So
yeah.
I wanted to try that.
Yeah. Do what Townsend Brown did. He used foil, aluminum foil, tar, and then beeswax or paraffin wax, they call it. That makes an excellent, actually probably the best electric. Yeah.
Okay.
And are you using that as some sort of capacitor to accumulate charges?
That's exactly what it is.
Okay.
Yeah. You want to hold, because he's creating a huge electrostatic field. You want to retain that field and build off that field. You have to have a foundation to hold it there. So the longer you can hold it there, it makes it that much easier for the field to actually increase in size.
Yeah.
If that's what you're looking for. So
yeah
I would definitely look into an electric type design.
Yeah, I'm pulling in radiant spikes from the ground right now. When I changed the magnets on it, I went from neodymiums to just a rare earth magnet, fridge magnet. Completely changed the whole program and allowed my static field to grow faster.
Yeah, you're using a ferrite magnet now?
Yeah. Because before it would just create heat to the center plate. Center plate's cold energy ruins the whole effect and kills the process. So now I have no heat to it. I can keep it off a little more and perfect. Just fills up the field with energy.
Yeah, I think ferrite's the way to go for what you're doing.
Yeah, I didn't realize that until probably a month ago.
Mm-hmm.
So
yeah, even John Bandini, he says when you build his Bandini motor, do not use neodymiums, use ferrite.
Yeah, it was exactly that made me look at it and go, I'm doing something wrong here. There was a reason he used the Linko magnets because they're still ferrite magnets. They're not, neodymium. So just a difference in how you see it.
Yeah, you have to experiment with this stuff.
I know he did explain the reason why you don't use neodymium, but can you refresh my memory on that?
It heats up the core. Is what happens.
That's right. It does. He said it.
And it puts an unwanted eddy current in it that creates heat, which changes your electricity from a potential to a voltage in a magnetism way.
Is it because it's too powerful, the magnetic field?
No. Because you want to keep it potential. You don't want to convert. And when you add the heat, it's converting.
Right.
Yeah. That's
slightly true and slightly not accurate.
Well, when it converts, you're get the heat.
It's got more to do with the duty cycle than anything else.
Well, it heats up the core and puts a magnetic value in it. That's changing the electricity.
The Neos keep the core saturated and the duty cycle stays longer.
No, the Neos are bad. I'm going to tell you that right now. If you're using a cold energy system, ask me for potential.
Core.
No. When you're using a cold energy system and you're talking about potential, you don't want heat. And that's why he used individual rods for the core instead of one bolt. It's keeping the heat out.
No.
Yeah, it is. Oh, he said it in his video. He said
doesn't want the duty cycle to be extended.
Trust me, he said
it clear as day. Magnet will saturate the core and extend the duty cycle of the switch. It's very simple.
But that's not exactly what you want to do, Mike. You're looking for.
Of course, you don't want to extend the duty cycle. Neither does Bedini. That's why he doesn't want to use Neos, because they saturate the core.
And he says it saturates the core, just like I said.
And it extends the duty cycle by doing so.
So
keeps the trigger down longer.
Speaking with the experience on this, because I've been working with these pulse motors for years.
It's got nothing to do with
if
you
have
up the core, but it's more to do with the duty cycle than that.
If you have a neodymium magnet wheel, the proper way to utilize that is basically to the point where the separation between where the core is and where the magnet is. Everybody puts their magnets way too close to the core. I back mine off almost half, maybe 3/4 of an inch. So when the field of the magnet comes in contact with the core, it's basically just touching it. So when you create that current through the core, it's not actually hitting the magnet directly. It's only touching the actual field of the magnet. You see what I'm saying? You're
Yeah,
not
the more your
bombarding.
gap is, the less
Yeah.
duty cycle you
So
create.
you can use neodymiums, but they have to be set up correct spacing between the core and the outside of the field of the magnet. If you get that just right, you will get the
Right,
same
but the
effects.
basic concept between the gap of the magnet to your core is, less of a duty cycle.
Critical.
The closer
It's
you are, the more
critical.
duty cycle you create.
It's very critical.
That's
The
10
further
times
your
harder with that
gap is, as long as you
neodymium
can
than
create a
it ever
trigger.
would be the ferrite.
Sorry, go ahead.
See, whenever I've put my wheel too close to the core, I always get hysteresis. I always get the heat. The second I back the wheel off away from the core and leave like a 1/2 inch to a 3/4 inch gap between the two, the hysteresis disappears completely and starts operating the way Bedini designed it to do. That's
Because
if you want to
you decrease the duty cycle, therefore you decrease the amps going into the coil, and you don't heat up the core or the coil. It's simple. So a very short duty cycle is very little amps.
The duty cycle
The
has
more
to do
you
with
hold
the
down that switch
transistor
with a
and-
stronger field, the more amps you allow through the transistor. So the weaker your field that triggers that core, or the weaker field that triggers the transistor, the shorter the duty cycle is, and the less amps you're going to send into it, and therefore the less heat.
It's going
But it's
into
more
a
about
switch.
duty cycle.
No, it's going into a switch that's set with the duty cycle. The
Actually, the
MOSFET's
wheel
set.
and the magnet
It's
determine the duty cycle.
There's look, the speed of the wheel is by the
duty
energy
cycle
in the machine. Yeah,
Determines the duty cycle.
But never mind. I don't,
The speed of the wheel determines the duty cycle.
Correct.
The less time that magnet sits over the core, the less time that the switch is closed. So the faster the wheel goes, the faster the switch closes and opens, and the less time that it's closed.
Is there a difference between spinning clockwise and counterclockwise in effects?
If you're running your motor in the northern hemisphere, clockwise. If you're in the southern hemisphere, counterclockwise. That's what Tesla says. He actually writes about this. So if you're in the southern hemisphere, counterclockwise.
Because I've heard the exact same things with how you wind the coils for electroculture, depending on which hemisphere you're in, and having results in that exact same way.
Same deal. Same deal. I think we need Gerald in here for the electroculture. He's the one who's the expert at it than I am. But that's what I've read anyways. But if you get orgone energy, it doesn't matter what hemisphere, you don't have to worry about it. If you make the proper orgone accumulator, it's going to work.
So what is orgone energy?
Well, now we're going to have to do actual tests and try spinning both ways and see if there's like a heat difference and like a maximum speed difference and stuff like that, right?
Well, what Bedini described that created his cold, section of the switching is the negative portion of the flyback was the negative energy was keeping the temperature down, so that's part of it. But if you have your switch down too long, you're not going to have that negative signal show up on the flyback. It's just not going to be a flyback signal. You have to really switch really quick on and off to have that radiant spike. The way he describes it, with the up and the little bit of down there at the bottom, there's a negative signal coming in, and that's where all the cooling off occurs.
In his motor, no matter what speed he goes at, the heat stays low. So, so it doesn't matter the duty cycle; it's about the heat, and you cannot.
Well, I mean, let's keep in mind you can change the duty cycle you can also
duty cycle does not matter because it'll go.
Well, let me just fill you in there. You can keep your duty cycles constant by creating a larger gap in your magnet from your core and slow down
Well,
the
that's
wheel and
fine.
still have the same duty cycle
But
that you had
his
before at a
motor
higher
goes
speed.
faster, okay, and it produces more as long as he doesn't have the heat. That's what I'm telling you. His duty cycle goes up and down, and that wheel goes faster and slower, and it would not matter whatsoever what his duty cycle is. That's the rate of charge when he has the duty cycle. The heat kills the core, which kills your cold energy and then stops it from working properly. You're going to get just a dirty voltage, and you do not want that. That
Yeah,
was
you
the
won't get
reason.
any heat if you keep to his philosophy of not letting the current in the first place, and that's done by creating a very
the
minimal
current gets
duty
in there,
cycle.
but that's why you have multiple rods in the core, so it disperses the heat, so that you don't get the current. You get a minuscule current, and then it goes away. It dissipates quickly, so you get a little bit of heat and it dissipates. So he keeps the cold energy flowing, so it stays as potential.
Right, but focusing on duty cycle, you want like a 5% duty cycle, not a 90%, because that would create heat.
I'm just saying, I saw his motor and
Because the amps go up, when
he
you got a
runs it
90% duty cycle.
faster. He runs it faster than when he starts it,
You're not
and
getting
his duty cycle goes up. He brags about it.
Well, I must have missed that.
Oh yeah, he talks about it. It goes up 10 to 15% easily.
Oh, here's
I mean,
Gerald.
Trust me, I've been watching this thing for the last month.
Well, maybe if he saturates the
Gerald.
core by, passing the magnet.
Mike, have you been watching Mike's videos on the production? Because it sounds like you've missed out on some things that.
Real quick,
See,
Mike,
I've always used a disruptive discharge switch. I'm not a fan of MOSFETs, SSRs, all that stuff. You cannot get the same effect. The second you have a complete disconnect from battery to your circuit, the current goes to zero. Gerard Morton even talks about this. That's why if you get the timing just right on my motor, my current on my meter doesn't even register.
real quick, Mike.
Basically, I can run my motor with dead batteries, right? And it'll run for days and days and days and days and keep going because the disruptive discharge of the release. That's why I don't use MOSFETs. You don't get the same effect. There has to be a physical disconnect. That's what I've researched. That's what I have found, and I'm sticking to it. Right?
Mike, you mentioned Oregon Energy. Could you explain to me what that is? Is that just vacuum
Oregon,
energy, or is that different?
Yeah, like say electrostatic, it
Oh,
hovers around electrostatic. So if you have an ionizer, Oregon is present. And Wilhelm Reich talks about this in his writings.
Okay, so you
like
can consider it maybe a form of vacuum energy then. Through
it
the
is.
electrostatic. Okay.
So he calls it Oregon. Other people call it vacuum energy. Other people call it radiant energy.
Oh, it's
just
okay. I'm just trying to understand. The terminology is so fractured.
Well, everybody has their own take on it, right? Everybody.
We're on the Gerard Morin device now. We kind of skipped from the Bedini to the Gerard Morin, so
No, well,
combine them all together.
It's working with the same
Alan, how you
energy
doing?
spike. It's the same thing.
Gerard Morin just uses the spark gap like you do.
Right.
$50 watts of light on like 23 watts. So spark gap, I'm not using. So I don't know. I'm just saying. I think there's a little bit more to the Gerard.
Gerald.
I think there's a little bit more to the Gerard Morin device than meets the eye. I think it's a PMH with instead of a solid plate locking the magnetic field in, it's a rotating magnetic field.
That's right. That's exactly what it is.
So that's what this little washing machine motor is, and if you know how to tap that right, I mean, I don't know. Just saying.
Because he has a U-shaped core, doesn't he? He has a U-shaped
so
core.
that washing machine motor is a U-shaped core, and the coils that are on it the
There's
end
two
of
of them.
the primary goes into the beginning of the secondary.
Right.
Yeah.
Yep. So it's a rotating PMH. So we're talking Scallan's work,
Yep.
That's where he was. So, some of these guys, in different time periods have kind of crossed onto the same thing, right? And Gerard Morin and Lee Scallan, they were working on the same stuff.
This high voltage thing is not amps, man. It's like a I look at it like a light energy. It's not a motor or like a locomotive type energy. Although it can be, you can use it for that with specialized stator windings, and do that. But it's more of a light, high voltage, lighting energy.
The potential.
Energy. Yeah, so lights will light up. They won't need, because it's not the same. It's not the same form of energy as we create at 120.
See, the problem is the standard. The standard type energy that we use every day in our lives.
Let me finish, Mike. Let me finish. I was just about to finish. The kind of energy we create contains current, amps. This energy does not have exactly that. It has volts and potential, which pretty much draw the conversion of those volts into amps from everywhere around it.
Yeah, just by the very flow from the high voltage to low
There you
voltage.
go. Think of it like that.
Creates the amps itself. So there is amps there. It's just you got to know how to convert it and pull it out.
You got to create an antenna to attract the conversion event. You got to an antenna. You got to create a signal to convert the voltage that you're generating with the Gerard Morin device or whatever it is, the high voltage potential with the next to no amps behind it. That form of energy you're generating, it can be transmitted like limitless distance because it's such a high voltage. That little milliamp in there is going to go pretty much all across the world, because of all that voltage behind it. So the lights are going to light up. All the lights are going to light up. You see what I'm saying? There's nothing stopping that 1 milliamp from going through all those lights.
And that's
I don't know how many. Go ahead. Sorry, Mike.
What's his name? Don Smith. He was the king of being able to convert high voltage, high frequency power into lower voltage, lower
there you go.
hertz level to run transformers. So Don Smith had a very good handle on energy conversion from a high voltage potential to a lower voltage and high current potential. And Tesla was talking about this stuff, and people just it right over their head. They didn't understand what he was doing.
I'm gonna show more.
We're used to filling up the bucket of water and dumping it. We're used to that kind of thing, like we feel the weight in that water. We're not used to, picking up a bucket that doesn't have weight but has all the energy in it at the same time.
Yeah, it all boils down to energy conversion. That's it. Yep. It's energy conversion.
Create a high potential and then create something that will accept that high potential and step it down. It all comes down to flipping.
Yeah. Right.
Correct.
So,
and that requires a stator winding that's capable of receiving that high voltage. Most stator windings only have a certain number of turns. They don't have enough turns on them.
I'm going to show tomorrow in my system that on the inner of the coil and the outside of the coil are two different frequencies and two different voltages, all running from the same function generator.
Yep.
So not all systems are alike, Mike. That's all just my point is. We all are based on the same thing, though, I'm seeing. It's all rotating, counter-rotating fields.
As soon as you change the frequency, you change the voltage.
That's right.
Yeah.
You immediately changed it.
Well, go ahead.
They bring in the high voltage from the lines, right? And they convert it. And in the conversion is where you get your 50 or 60 hertz.
Yep. And your amps are right there.
Yep. That's right there in the conversion.
Yeah. When you're doing a step down from, high voltage to low voltage, you get the lower voltage, but your current increases. If you're going the other way around, when you go high voltage, you lose your current.
Well, I know what ratio
You have to give up
use in
current to
order
make that
step.
high voltage.
Is it like the phase transformers, like the three, like those electric lines where they have the three things
Yeah,
there?
that's where it switches down. Yeah, and then it goes to the box on the ground, steps that 44,000 volts that comes from the high voltage lines, drops it right down to 120 or whatever your voltage is, 120 or 220, wherever you live. And then that's where the current increases right at the box outside.
Right. But on the step down side of that winding, it needs to be thicker though to handle the amps that's
right.
being converted into. The volts that are.
Yep. That's
you
right.
know, the volts from the they have the same amount of mass, but less turns on the step down side to lower the voltage. But that winding has to be thicker to handle the amps now.
Yep.
Don Smith's rule of thumb was it's either a quarter or a half wavelength or size of the wire. So if you got say a 20-foot as your primary and you're stepping it down, you go to a 40-foot. So that's where the conversion has to be equal and opposite of.
I don't know. My system's a little different. I got 120 wraps on all my pickup coils on the outside. And then I can take that same pickup coil and put it on the inside of the core and get more voltage on the inside core than the out, right? But they're the same windings. So I don't quite know. I mean, the system's differently. There's a pinch in the middle and it defeats Lenz's law and there's a few other things going on. But yeah, I'm just curious about that because I think I have the right ratio now of how much volts I have to put into the system to create the outside being 120.
What's your ohms?
Gerald, I think
What's my ohms?
Yeah, on your coil.
It doesn't really count that way. I mean, it's 6 ohms, but it's bifilar. So do you understand what I mean by that?
What is the ohms of the coil? Then you know how many volts you got to push through it.
There's 6 ohms on the primary.
Yeah, low voltage will do that.
6 ohms on the secondary.
Low voltage will do that.
It's the opposite.
I can put low voltage through it or high voltage.
You can do high voltage too, but low voltage will get through there. There's just not a lot of resistance.
But I think the geometry plays the most important factor because you're compressing the fields in such a way where the windings don't really matter. You're getting that radiant energy into the system.
I hit it with one pulse and it creates spin. So what would you call that? Some would call it a prime mover. I don't know if I go that far, but I literally can hit with one pulse and it creates spin if there's a magnet sitting on the inside of it.
Is that 12-volt pulse?
Doesn't matter. I can do it with a 1.5 volt battery. AAA.
You've created a dipole, right? So the idea is now you got this dipole. The worst thing to do is to have it in a closed circuit. Keep it open. Have some way of drawing the external power or radiant energy into the system. Bearden talks about this all the time.
Bearden's explanation of the dipole is just every time I hear it,
it's a closed circuit.
It's beyond accurate, man. I mean, if you want to learn about,
do we have a video or any kind of quote from him on that?
Well, the energy from the vacuum series. If you watch all of the segments on Bearden, he talks about this, and he says the only way you get free energy or vacuum energy into your system is to open up the closed system.
Right? Yeah, the Bearden quote has something that he describes you don't destroy the dipole every time you cycle through is the key part.
You can tap off it, but it cannot be direct connection to the dipole. Has to be
that
separated.
does sound familiar.
Okay, so this is
separated by like a diode or whatever, right?
Well, no, it cannot be attached.
It's charge separation.
Well, the diode separates it. That's
it doesn't.
Yeah, well,
no.
Houdini said the diode is isolating It's an isolated switch.
Yeah.
It's one way.
It's an isolator, but it's not a charge
It
separator.
allows the dipole to exit.
I was going to
So
ask
basically-
Nathan.
At least
Sorry.
positive then.
So I was saying basically the pushback from the aether is what destroys the dipole when not used correctly, when the system isn't made correctly.
Actually, if you don't pull enough energy out, you'll create heat, and that's kind of part of what I wanted to ask Nathan. When you're pulsing your primary and you put too much current into your primary, that sucker heats up. But now if you're taking your secondary and you're that system, then the wires themselves are capable of doing, which I still to this day don't understand, but it is what it is. So my point was, when it comes to the heat and it popping up, I wonder if there's a way of me using that mechanism to create that heat and then drop it into the next coil really quick.
Okay, so let's just look at a Tesla coil, right? I put a ZVS circuit onto it, and the ZVS would normally, if you don't have this thing oscillating, would actually heat up the number one coil, and it would just fry every wire that's on it. Now, when it's oscillating properly, I can use a 10 times smaller wire than what I'm supposed to use for that amount of energy. It's doing the same thing you're doing. You're getting it in the correct 1-2, 1-2 punch. You get what I'm saying? It's allowing one to go. The second one goes, then the energy disperses out somewhere else. You see what I mean? It's not backing up anywhere. So,
yes, I get that.
So
You're
when
creating
I take,
a flow, not a disruption.
that's right. I have no what do they call it? Impedance? No stopping it.
Yeah.
It's 100% in resonance, so it'll allow it to flow. If that helps out.
It
Nathan,
does.
What's causing the Nathan? What's causing the ZVS to stop oscillating?
Oh, if you have the wrong frequency on your number 1 to number 2 coil, it won't oscillate.
It'll go constant current or what? Or
Yeah.
just will not.
Current will build up and spike, and then
right. That's why that's what's heating it up.
Fry everything.
Right. Yeah.
It
Why
doesn't
would it
matter.
go constant current though? I think it would just stay open. No.
Let's just put it this way: I could put a 1/4-inch piece of what is it, copper on there, just a hollow tube. Put it on there, and it'll still smoke. If you do not have it in resonance, it
sending
will
the
not
full
work.
amps through.
Yeah, the amps will just stay in the system. So you're putting
Right
a
from the
feedback
variac.
in that number 1 coil you don't want when you're not resonating.
Or turn into heat and burn out like the amps, right? That's the key part of needing it in
So what's
resonance.
happening here with Nathan is his thing stops oscillating, so the switch stays down and the amps keep going through. But when you're oscillating on and off, when you're off, the amps don't go anywhere. You're not using power. You're conserving. You're tapping power in.
Yeah, but now it all backs up back in your ZVS and fries it.
So a ZVS is basically like a square wave generator.
Sounds like the Tesla coil
Just
is
now
creating an impedance to back to. Sounds like the Tesla coil may be having too high of an impedance for the ZVS, the pulse.
You see, here's the thing. I have mine in perfect oscillation. Even if I have my gravity flyer on it, when I run a Tesla coil and it runs 250 kilohertz, my my gravity flyer is 275 kilohertz, is what it adds to it. So basically putting a top load on my Tesla coil. Okay. It brings my oscillating frequency down in the 300 kilohertz range. Okay. Excuse me, my coil was 600 kilohertz. So I brought it down 300 and something kilohertz. Okay. Therefore, my oscillating frequency is right around 360 kilohertz is where it oscillates at now. But it does it perfectly. The wire I use on it, I could use a little wire clip that you buy from the cheapie store that just clips on one and clips on the other, and it would still oscillate properly without burning it.
That sounds like Tesla's quarter wave, the third
what did you have to change?
I was talking about.
Because it's in resonance, and another word for resonance is coherence. And when you have that coherence, you're not losing that amperage into heat loss. It's going straight into electrical.
There you go, Bernie.
What did you have to change to achieve that? Was it just the capacitors on the ZVS? That's it, and that got you where you needed to be, or?
Yeah, change the capacitors. So I changed the nanofarads and went down. So
Less capacitance.
Yeah, 0.75 nanofarads is where I'm at with two of them. So they're 1.5s each, and then they bring down to when you hook them in series to go down to 0.75. Oscillates beautifully.
Yeah. Yeah. So you didn't have to change the coil or nothing, just the capacitors.
I built the coil specifically for this. I knew exactly where I wanted to be. I used the Java on the Tesla coil models and found out exactly where I wanted to be. I built the coil originally just to oscillate at the perfect frequency, right around 360 kilohertz. And then I built my Tesla coil for my Gravity Flyer in order to take advantage of the Gravity Flyer and exactly how much capacitance it has as a top load.
You're really close if you've got stuff in full resonance and coherence of getting that next pop up, right? It's already in that state.
Like I said, it's already doing some funny things, but I'll tell you this. My Gravity Flyer center plate, my Tesla coil, okay, and where the magnets bring in that spike, that radiant spike, all three of them ring at the same time. So what that looks like is, you know how you have that thing that goes like this and it gets bigger, and then all of a sudden, boom, it comes out and it shoots out your spark in your number 2 coil out of your Tesla coil. All three of them hit at the same exact time, and my piezo buzzer doubles the amplification on the height on your oscilloscope. So right now I'm hitting 25 megahertz just on the regular resonance in this thing. When it hits peak value, I can get that over 200 megahertz as soon as I hit the button at the right time. I'm basically creating a Tesla coil candle at the end and multiplying my
double
energy.
bounce on a trampoline, essentially, right?
So when Gerald did his coil experiment, just understand this. The jump that I get, when I get the double jump, okay, that's when I know how to back it down in order to get the hover.
Didn't you also say your experiments are making your son's speakers go crazy? If if the speakers are off, that's really saying something.
They're off. I can't even.
See,
I can't hit the button in the garage. Let's just put it that way.
No, that's not something uncommon. We've heard stories like that before in similar devices, right?
So just think about it.
Let me just say something about the speakers.
I have an EMF field, a bubble. Okay, just understand what that does. When you put that much energy into something that has that electromagnetic field bubble, okay, boom, okay, everything starts to fry around you because you have way too much energy going on. Okay, you start to ask, okay, how do I get that amplified energy to get enough voltage to lift this thing so I can get to a TT Brown? Well, that's how I'm doing it. I already found it. As a matter of fact, I could probably show you the picture of it. And
let me say something about the speakers, though. The coils on that are very thin wire and very many turns and capable of receiving very high voltages. Just throw that into your mind for a second there with your Tesla coil.
Sorry.
Your coil is made out of copper.
In which one?
The speaker coils are copper also, but they're high voltage coils, low amps.
What about mixing aluminum and also bismuth as potential alloys into them? I was recommended that for the magnetic side of coils, for the magnetic current or flow force.
Yeah, but you still have to insulate the coil so it doesn't short out on itself when you wind it up. That's what happens when you make those alloys. You have to find a way to put the enamel on that alloy when you're done. It's an expensive process if you want to do it yourself.
Yeah. Well, I have not done it myself yet, right? But
I mean, to make it affordable, I think to make it affordable, you could melt metals down and then create a wire out of it, of course. And then the expensive part, I would think, was how do you insulate it so that you can wind them close together and get your high voltage. And that's the thing I don't know how to do. You need to research how to get enamel coating. You could just buy liquid enamel and submerge the coil in it, maybe try that and let it dry out and see if, then after that you have to wind it. It's a lot of work. When you could buy a spool already made and insulated with enamel and everything like that, it's a big time saver, huge time saver.
Can you see it? Is it up on the screen?
We got it, brother.
Okay, check out the 3 spikes right there. See the ringing? So all the amplification is happening at one point and then it goes dead, right? All 3 of them hit. Now, all I have to do is turn a dial and they all overlap each other. So just imagine that all 3 frequencies are hitting at the same time with the same ring.
So then you get that triple bounce of like a trampoline, but on.
You see, I'm already at 23 megahertz on there. It shows it on the oscilloscope, right? So just imagine when I amplify this thing, those little waves that you see there, there's actually probably an inch more on each side that it gets. So it's a huge amount of energy
Levels, because basically it's once you have the system in resonance coherence there, then when you amplify it, it's on you have it on a full scale of exponential increase sort of thing, and each magnitude up is on exponential increases, not just small tiny things, right? Because you have the whole resonating or coherent system circuit at that point being amplified by these larger forces.
Because the center plate overtakes everything and gives it the same frequency. It's self-correcting. That's why all of them are exactly the same. So when you turn the dial, they overlap each other. So the amplification from the piezo button you get amplifies all of them at once.
All 3 plates?
All 3.
So are they in phase, the signals? All 3?
Yeah.
They are? Okay. And maybe they shouldn't be in phase. Maybe they should be like 180 degrees.
We're you know what? You get the massive amount of energy when they're in phase. That's why you have to tap the center plate in order to do it. And if the piezo buzzer hits hard enough, it'll tap the center plate for you.
But what I'm saying is maybe it's not the massive amount of energy that makes it get lift. Maybe it's the opposite. Like
I don't think you're understanding. I'm taking a pressure bubble and I'm amplifying the amount of power inside of it. It's like a firecracker in your hand. Okay. Take it out of your hand, energy lost. Put it in your hand, energy blow off your hand.
I see where you're going with this. Yeah.
I'm doing a rapidly expanding field.
If I apply my own theory to the gravity flyer, if you have an energy potential, you're gonna have a shift for sure. So it all makes sense. So keep going, man. I believe it can work.
Nathan, what do you think will happen if they were 90 degrees out of phase or whatever, 180? Did you ever try that? Or?
Every time you hit it and they're not correct, it does nothing. Yeah, it does nothing.
Is the energy like kind of isotropic or the same in all direction, or is there a potential or a difference?
So it builds bubbles. Is what I like to say. So if you take it, the Tesla coil is hooked to the center plate, right? So it builds a field it builds a bubble that'll push all the other energy around. So as it's on, it'll hold in. It'll just turn on and hold in your high voltage like this, right? In that bubble. If you flip the field to the between the disc and the plate, it'll actually force it out. So it's containing it at this point when you have it this way. So you're getting this, like I said, a massive bubble of energy. And because it's a capacitor to ground, those energy spikes of potential are bringing up the energy to the center plate because I don't use the neodymium magnets.
Yeah, you're doing everything. I know exactly what you're doing. I can see it perfectly. When you make that bubble, have you ever tried using an AM radio? Just like walking around your room to see how far out the bubble goes to see if you can pick up the frequency?
I haven't. I probably should.
You know what? I mapped the bubble that I was making with an AM radio.
Really?
In between stations, yeah. I can literally hear the frequency in the radio, and as I would get further out, it would literally cut off very quickly, and then I could walk back in like half a foot, and boom, there it was again. So you can literally like hear the edge of the bubble. So I don't know if that'll work for you, but maybe.
That's neat. That's really cool.
Yeah, usually I just use the lights and it tells me exactly where it is, and I can adjust the high voltage and Tesla coil and maneuver where it is, and I can amplify the outside edge of that bubble at any time that I want to by setting them close to each other.
That's cool.
So, anyway,
It's almost like it's an electromagnet to some degree.
But it's all in potential and in charge. It hasn't magnetized until you release all the voltage, and then it'll instantly magnetize until it goes back to cold energy.
Have you ever checked to see if the aluminum is getting magnetized with
It's not
a magnet, like a magnet?
No, I tried it. It's not.
It's not.
It's pushing off all.
Well, I mean, I'm not saying while it's off. I'm saying I know this is dangerous. I'm saying while it's on. Have you ever? Because the magnet can pull you to it. So
I walk right up and touch this thing.
I know you got the balls.
It's
so I'm asking
cold.
you, have you ever taken a magnet and like seen if it's pulling your hand or pushing your hand or the aluminum?
Yeah.
I mean, did it do that?
No.
No.
The center plate isn't magnetized at all. The plates on the top and bottom get magnetized.
They're aluminum.
But they're pushing it off. Pushing it into it.
You're saying you made aluminum into a magnet. That's
Just listen. There's a field that surrounds the aluminum that will not actually penetrate the aluminum. That's the potential. That's why it's not magnetism yet. It's potential.
But there's a field there, and it's making it look like the aluminum is a magnet, but it's I got you. The field is generated by the.
It's spraying off basically. What do you want to call it? Static electricity.
The eddy currents flowing off the aluminum or generating.
Yeah, you go over, take a dryer sheet to it, and it'll just go absolutely nuts and turn off your computer, everything. And it'll start binging, bonging, and everything in the whole room will shut off.
Yeah, didn't you say it like pushes all the electrons to the edge of the plate or something?
So the edge of the plate is you could feel
it's styrofoam.
It's cold, but it'll burn your finger every time.
Huh.
It's cold energy. It's just there's a massive amount of energy, but it's cold.
Right? Cold electricity is a thing.
You ever try styrofoam around it? See what the styrofoam does?
No.
Yeah, that could amplify the static field for sure.
I put paper on it, and the paper charges it up real quick.
Yeah.
It'll like I said, paper works just like a dryer sheet.
But styrofoam and then aluminum foil, and
the problem with the styrofoam is you're going to burn it before it charges fast enough. It's a slow charge in styrofoam, and then it'll stay longer. But it takes a while to charge styrofoam. Paper charges instantly and then discharges instantly. So there's a difference in the material. If you want a steady charge for a long time, use styrofoam. If you want a quick charge and discharge, use paper.
Yeah, the styrofoam has more density.
Static electricity.
Fast charge. It seems to be able to charge stuff up real quick with it.
it will also burn and combust very quickly.
Have we had some news from LSC, the author of the Gravy Flyer?
Not that I'm aware of.
No.
I haven't been in personal contact with them at all. The Jared and Charlie C do, but I it's not my area.
You ever try putting a stator coil around the device, see if it's picking up volts and stuff on the stator?
I could put a coil right next to it and see what it comes out at. I mean, it'll tell you right on the oscilloscope what kind of energy it's putting out.
So I don't know if this counts. This is a question as much as kind of a weird statement. So when I run my coil, I can take a ferrite pickup coil, put it in the center above the middle horizontal plane, and I'll pick up energy. and then I can take another one and stick it below the horizontal plane, and it'll pick up energy. But the weird part is I can take a compass at that point and bring it close to the bottom coil, and it will read north, and I could bring it close to the top coil, and it only reads south. So it's like I'm splitting the poles. Has anyone else ever experienced that?
Well, you're getting the vacuum energy, so you're gonna get poles. You're getting a massive vacuum energy actually from what you're doing.
Okay. I just wanted to, it was a question, like I said, right? I wasn't exactly sure if that was normal when it comes to
I mean,
what I've been doing.
questions are tough. For you ask it questions to, like, engineers, we can't really answer them without the diagram. I mean,
Have you held a digital pole detector up to your coil, Gerald?
That's what he's just saying. He just did a compass, and it was telling you.
Yeah,
what
I
to
haven't done a digital one. I need to get the 3-point axis meter there, but I use compasses. And
well, the reason why I'm asking is because when I did it to mine, and when I recently found the North Pole, which I didn't find before, it was really odd. It wasn't like bleeping back and forth evenly. It was like bleeping south, 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 and then the north, south, south, south. Like it wasn't like south, north, like bouncing
those
back and forth.
pole detectors, I used to have one. I just got rid of it. They're not so reliable.
Hey, Gerald.
It is a cheaper one, to be honest, but
in the Makaba generator,
the magnet is the only way.
Remember we watched the Makaba generator?
Yep.
Okay. So he pulls a north and a south depending on what frequency he puts into his machine.
Nice.
That explains it. Yeah.
When he changes the frequency of his coils, remember he had it hooked up to the stereo thing, and he's changing the frequencies. I have the video. I'll send it to you.
Because you're shifting the magnetic field geometry.
Yeah.
He's changing the volts and amps when he changes the frequency, so you may get.
Put the video in the private chat. I can bring it up and we can play it if you want.
Awesome. Thanks, Nathan.
Okay.
But what I'm talking about, though, and I get that, but I mean, like, I split the pole north on the inside top of the coil and all the way on the outside top of the coil, and then it's south on all the bottom. Like, do you know what I mean? Like, I don't know if that matters. I don't know. I'm just maybe.
Well, I mean, you have north on one side and south on the other. What's so out of the usual there?
Because when I take the pickup coil and I put my compass close to it, it doesn't read north and south on the pickup coil. It reads just north. Or if I go above my vortex coil, it reads just south, depending on how I'm pulsing it.
There you go, Benny. It's
hard to understand what's going on there.
I actually use the hairpin circuit quite a bit.
Your secondary coil is the pickup coil, right?
Say that again, Mike?
So your second coil is the pickup coil?
No. My second coil just it adds to the capacitance of the whole system. What I do is it captures the back EMF, and then I convert it and send it back into the system so that I can keep the dipole running at all times. And I use ferrite cores with 120 wraps along the outside of the toroid coil, or sometimes I'll put them on the inner core.
I saw that. Right.
So you don't lose energy this way?
None at all.
Those are your pickup coils, okay.
The only time I lose energy is when I'm using something like really large, and even then I'm not losing energy. It's strange. I can use up to, like, I don't know, I've seen 100 watts go through the primary as I was using 1,000-watt electric element, and it was heating up. It wasn't going red, but it was heating up. So it's interesting how it works.
I wonder
if I
use the ferrite.
Gerald, if I saw your diagram one time, I'd be able to, understand a lot better.
I'm not so sure. Me and Jeremiah talked for 3 years as I explained it. I even told him how to build a coil.
But in 3 years, did you see the diagram? In those
What's
3 years,
that?
in 3 years, did he see that diagram?
He's seen more than one.
Well, I ain't seen none, so I don't know. I have to imagine.
I understand, Mike. I'm not faulting on your abilities whatsoever, dude. Not at all. It's a little bit complicated to understand the winding system.
I don't even know what your connections are like, so.
Yeah.
Do you
Go ahead.
think that if I use a ferret core and use some windings like you have with my rodent coil, do you think it would pick up anything?
Yes, but I don't know where it would pick it up. Because the way that the rodent coil is wound, your compression field is just in the center. I don't think you're going to pick it up on the outside.
Right, yours is what, spilling out into the outer.
Mine's pushing it out like.
I think the rodent coil was designed to be not needing a core. That's why it was geometry. That's why it has that geometry.
But you can
Yeah,
use
mine
it
doesn't need.
You can use other. Well, you can use other rodent coils as pickups for it. Like if you make another rodent coil and sit it on top of it, it will induce the electricity wirelessly.
Do you have to have a rod that goes through the two when you do that?
I don't think so. I've seen First Stop Energies just have a big primary coil and then the pickup coil and just set it on top or put it right near it.
I get that.
I mean,
see, my field pinches
so
in
narrow
the middle.
that you need a narrow core.
My field pinches in the middle, and because of the way that it pinches, it pushes out like a mushroom horizontally all around the coil, and then it creates a thin line on both sides, up, below it, and above it, and it splits the poles.
I would try a hadron shaped core, like an ice cream cone.
Yeah.
Shape, piece of iron.
Oh, yeah, that'd be interesting.
That's what I would try. Because I think that the field is compressed narrowly, and you might be able to capture it at the tip of the ice cream cone and spread it onto the rest of the iron mass in a 90-degree angle on that cone.
I've tried lots of different shapes, and the funniest shape that seems to work the best.
Or 45, you could try different.
It's actually a horseshoe, just like the PMH.
Huh. Yeah. Wait, PMH, what's that?
Horseshoe magnets Ed Leeds Gallon used on his flywheel too.
Maybe
right?
even try toroidal.
Right.
Yep,
That's
toroid
right.
core.
Oh my god.
To that shape.
Also,
and that
toroid coil.
The horseshoe stays open on the inner core, and it's closed on the outside, and you wrap the coil above and below. And you cross, like I said, the end of the primary gets wound to the beginning of the secondary when it comes to the horseshoe.
Ben, you can find toroid coils ready to go, all sizes. Try different sizes.
Yeah, I got one left over from my a small ferret core wrapped with a wire left over from my Tesla kit that I can use. I can mess around with that a little bit, maybe this weekend if I have time.
The one that has the most pull or push is the right geometry.
Mm-hmm. Yeah,
just
no,
take a speaker wire and wrap it in circles and create a bifilar coil, and then put it underneath your device and see how much it picks up.
I don't even need to do that because I have a spool and it's already wrapped around something. So yeah, I could just maybe put if I need to put a little core inside the hole where the spool is. But I don't know. You think that would work?
No, it would work. Yeah, you got a coil going against a coil. You're gonna give off energy if it's high enough.
Yeah.
If you got a high enough amp, you're gonna reach it.
But with an air core, or would I have to put some kind of metal inside?
No, you do with the air core. It's just a coil. You're taking a coil and pulsing it to another coil.
Right.
Yeah, it should be.
But the core helps with the transmission to the secondary or whatever. The core, I mean, it helps with the capturing the field better.
Yeah, I know.
Instead
like
of
you
losing
guys said,
it to the environment,
different geometries can interact with it in unique ways.
I'd stick a piece of 1/4-inch copper pipe, real flexible stuff. Put it right in the center of the outside round part. Okay, so like you're inside of it, the Tesla number should be really high inside there.
Galvanized pipe.
This a horseshoe magnet like this?
Yeah.
Yeah.
You guys are talking about the
More
thing that Andrew
you or all the way?
It's been a while since I've seen one of those.
Okay, and this is the wire. Are you talking about wrapping it like this?
No. So take each end of the horseshoe there, okay, on the ends of the U. Now he just wraps them on each side, and they have a little piece of plastic in between.
So I wrap on each side, like.
There you go, just like that. So he has a little piece of plastic to hold it off of the actual thing, and it's just soft iron plates connected together. And then he has a magnet that goes in the center, and it's just a round magnet that goes in the center of that device.
Around there. Like something like this.
Yeah, the coil is to be energized with a battery.
Yes,
Tapping it on a battery.
There you go. You got the soft iron core like this, right? The wrappings go where my fingers are. Okay. See my fingers? The wrappings go here on my fingers.
Okay.
Here's the soft iron core. It actually curves in like this at a rounded part at the bottom.
Okay.
There's a little round hole right here, and the magnet goes right in there, and it just spins right in here, and it goes inside this thing right here.
Okay.
So that's it, and then it covers like that on the winding. That's it, and then it goes from one to the other one.
Okay, I'll try that.
There's two wrappings in series around each arm, right?
It's completely wrapped on one side, and then it goes over the other and completely wraps all the way around.
Two wrappings around one wrapping around each arm in series, right? So you wrap around each arm with the same wire in series.
Yes. Sorry.
Which is found
around
counter one.
Confirmation.
Like all the way? Do I do the wire all the way all around the magnet?
No. You got one wire. Let me do this.
Maybe about an
one
inch.
Wire.
About an inch, yeah.
Okay, about an inch. Okay.
Yeah, it's about an inch high, is what it is.
Okay. Let me see. While you guys talk, let me.
I mean, you can put the wrapping anywhere on that thing, on the top or the middle. It doesn't matter.
No. The way this thing is built, just so you know, the washing machine motor, it's 1 inch.
Yeah, and it goes. You would wind it, say from you'd go up the one side to where it ends, and then you would just take that wire and go to the other leg and just wind it down so that it's wound counterclockwise and clockwise at the same time on that one same wire.
I need to get pliers. All right. Thank you.
So when the current enters the wire this way and goes down the metal, that's the same direction the North Pole will be going. So the current enters the wire, goes around the metal, down the metal, and the current goes down the metal, and the North Pole points down the metal. So make sure when you wind it, you're not going the opposite direction of the North Pole on that U.
Actually, you just helped me understand what's going on, Mike, by saying that. Listen, when he winds it.
Listen, I am a professional electrical high and low voltage troubleshooting technician.
Mike, stop. I like you. You're awesome. You're smart, but you were wrong. Okay, so listen. When on the U, when he winds it from say the middle of the U up.
On my eye there.
Like I said, I like you too, Mike. That's awesome. So listen, he winds it with one wire and he goes up and then he crosses and goes down the other. What he's doing is he's allowing the metal to take the magnetic field and he's allowing that copper to take the electrostatic field, separating it and then putting it back together when he goes counterclockwise on the other leg.
That's also actually what Keshi is doing in his Magrav coils now that you explain it like that.
Yeah, it's like completing the circuit, right?
Well, I have a different, more
it's
simplistic
connecting
view.
the electrostatic as well as the magnetic currents all together, like separating.
Yeah, like separating them and then bringing them back together and converting them. And that's how we're getting so much power out of it.
But you have a certain flow on that U, and it's north to south. I'm sorry, south to north. So when you do your counterclockwise, clockwise wrap, make sure it's also south to north, as in the magnetic flow on that U already, because if it's not, you'll cancel the magnetic field, which you can do that as an experiment, temporarily cancel the magnetic field. I'm just saying,
then it eats away the extra force just as much as it would be increasing it and nulls it into nothing.
Exactly. You could also increase the force of the magnet by wrapping the clockwise, counterclockwise in the right fashion, that the magnetic flow is already happening on the U, not the inverse flow, because doing that will
That's why the counterclockwise and clockwise are so important on which way it is, whether you're northern hemisphere or southern hemisphere. And it's not just on like where we are on the planet, but also where you are on the magnet and how you're wrapping it.
See, like-minded people, it fix the world's problems. I love getting together with a group of people that have brains. Just
Guys,
saying.
you do know that you could take a U-shaped magnet and make it south only.
I got a question about that wrap, Gerald. We were talking about on
you
the
can
U.
take the winding and make it south only, or you can
But
take the
both
winding
are
and make
just-
it north only on a U-shaped magnet. Okay.
Huh,
Just making sure you guys-
Yeah, but if you
What
go
if
in
you
the
wrap-
wrong direction, the winding is just gonna shift. It's
Right.
gonna
What
move
if you
because
wrap the
of
one
the
winding
motion.
so the north face is down, and the other winding so the north face is up? Then you keep the flow going, right?
Just want to make sure you guys understand.
Yeah, it's kind of like creating a dipole.
Or if you turn the counterclockwise wrap around so the north is facing down and you got two norths hitting each other.
It's a rare video I watch, guys. That's it. It just showed you everything about the U-shaped magnet.
No, you're right. Actually, you're absolutely right. I might have seen the same video on how it works.
I've never seen it. That may explain why it's rare.
Well, it's it was probably somewhere around 2014, 2015, if I remember correctly.
That's all in black and white.
Probably long
video.
Do you have a demo, Nathan?
Do I have a demo?
Yeah.
Of what? The magnet?
The gravity flyer?
I have it behind me.
Okay,
It's
so
I'll show you. Hold on. Oh, if I move over here. So
and just to explain why the windings matter in north hemisphere or south hemisphere, it has to do with the magnetic field of the earth, and that you're harnessing magnetic energy or from the magnetic current from the poles to the center, and it's electromagnetic, but it's magnetic, I guess, coming through, if that makes sense.
Yeah.
But it's the Earth's field, the Earth's magnetic field that you're harvesting it from.
Okay.
Nathan's got a mobile Graviflyer base, mobile base. I love it.
I have to go outside.
Are there two discs, another counter rotating disc?
Yes, counter rotating.
Okay.
So Bernie, when you have
It's
a
which
coil
way the
wrapped
Earth's
clockwise,
magnetic field is facing you. It's inverse.
Bernie, when you have two coils, one clockwise, one counterclockwise, both coils are receiving positive and negative on the same ends on each coil in this scenario. When you have one coil that's clockwise, the end that the negative terminal is on is where the north field is supposed to be, because the positive flows to the negative.
You're right with that. Sorry, I was just talking about the electroculture and those antennas going up and coming down.
So as I finish here almost with the counterclockwise wrap with the same connections from plus to minus on the same ends as the clockwise wrap, plus heading to minus, you'll have also a north on the minus side. But the spin will be the spin you're creating on the coil will be a different spin. It's a different spin, yeah. But you're still going to have the same fields based on the direction of the greater potential flowing to the lesser potential. Wherever that greater potential ends up, that's where the greater pole ends up, which is the North Pole. So the greater potential always going to flow to the lesser potential, and bring that potential up, and then thereby where it left now becomes the lesser potential. But that's another story. But that's where the pole ends up, where the greater potential goes to, which is the negative. The positive potential goes to the negative. We call it a negative. It's really a lesser potential to the positive. They're both potentials. One is greater, one is lesser. The plus is a greater potential than the minus. The plus goes to the lesser, the greater potential goes to the lesser potential, and that's where the north field is generated on that coil. So when the energy enters the coil on one end and exits the coil on the other, where the lesser potential is, that's where the field is generated. The north field, the greater potential, is generated there. The north is the greater potential, not the south.
Oh, remember that.
It's always the stronger field on all the magnets. It's the north field is the strongest field.
I did it. Good.
In the northern hemisphere.
There you go, Lulu.
I got it done.
That's a series route.
Very nice.
Okay, this is north. This is the north one. This is the south.
No, you just need to add like 120 amps. No, I'm just kidding.
Here's the magnet in the center. What am I supposed to see? Like the and this is the compass. Is it supposed to like change fields?
When you take the two ends of that wire and tap it to like a 9-volt battery, connect one end to the battery and tap the other.
You kind of did it backwards, Lulu. No offense.
I did.
From my understanding, and I could be wrong unless there was a different experiment that I was missing. Your cross wire where the open bar is supposed to be on the other side, and the magnet's supposed to complete the circuit in the open bar.
Okay, give me a few more minutes. I'll fix it.
My bad. I apologize if I explained it wrong. Unless there was something else that I was missing, Nathan.
Hang on, I was just looking for a video to show one.
Okay.
All right, I'll fix it while you guys look that up.
I have two of them sitting in my garage somewhere. I just don't remember where I put them.
Does it have to be like copper wire, or can it be like this kind of copper wire? Like the softer kind.
Like
one.
brass?
Like this stuff. Like it's the soft.
Brass.
It has to be insulated wire.
Okay, this one is insulated with something.
Or is it brass, not copper?
I don't know. But it's much softer to like move, like you see. The other
I don't know. Has anyone used speaker wire or anything like that? I know I use like magnet wire, so I mean I don't know. But it could work. Why not try it? You never know until you try.
Could have been aluminum too, yeah. Right, so to like replicate the first time, I'd probably do full copper, but then just to experiment and see if it works for the heck of it, yeah, why not?
How about real gold wire? Would that work?
That'd be expensive, and if you got real gold wire, I know a few coils I'd like to try to make with that.
I do. I have.
Heck yeah, I'd make a superconductor if room temperature if I had some gold wire.
Okay.
Right.
This one is real gold. This is real gold wire. This is I think it's 24 karat gold wire. I got like a little roll of it.
Yeah.
Yeah. I could do it with this. Would this work? And it's pretty soft. Very soft actually.
I don't know if it would work. Yeah, see, there you go.
Like, does it have to be touching the or could it be a space? Like how there's a gap.
Is that correct, Gerald?
Yep, that's correct. You see how it's wound? And then
does it have to be
the wire
tightly
goes
wound?
in the counter wound.
Okay.
What's that?
Does it have to be tightly wound, or can she just?
It should be. It's like every other transformer, right? But I mean, it's not. I don't believe it's an absolute necessity.
Well, either way, she could probably just put it on there and then tighten it, maybe.
A question: does the negative go to the south and the positive to the north?
So see the positive entering the coil there, and how it heads down the coil and up the other end of the U?
Yes, but the where the positive, because this one there is a north and a south. Like this one is a north. And
Right. Okay. So the north is going to be facing. Let me just draw it here. I'll show you where the north will be on the coil in each one of these coils. The north will be here because the positive is flowing that direction.
Okay. All right.
You understand?
Yes.
And then the positive is flowing this direction.
Okay.
Out the coil. You see? So it's going that way. The same positive, and that means the north is here.
That makes sense because North Pole's inflow of aether.
So I don't know if this is right, the wrapping, because I don't know where if this U magnet has its north here. Let me do something here. If the U magnet that you have now has its north here and it's south here,
yes.
Well, then you have to make sure that that you're generating. This is probably wrong. And then so wait, it's right if your north is here on the magnet currently.
Okay. Right.
So if your north is on the magnet here, then this is correct, because this is the positive energy is going to flow through the wire that way and generate the north here. Okay, that's where it's going to put the positive potential on this coil. It's going to build up the more positive potential on the coil right here. And the north will be there, not the south. The south is the weaker field. So, and that same positive potential continues to flow through this wire up this way and create the north where you have it now on the magnet. That's
okay, Bernie, I have a picture for you
of the magnet.
Yeah, so the idea is to take a piece of steel and put it across the energize it with a 9-volt, and then take the 9-volt away, and it should stay locked. That's the idea.
Mm-hmm. I have a 9-volt.
Look at that little machine. It's pretty. I love that.
Coils on it.
Right. Look at that. That's some heavy duty coil.
So you see the top, how it grips around the magnet right there, the top shaft?
Yep.
So there's that, and then you see the 2 coils on the bottom there.
Absolutely. It's a moving PMH. It's actually really perfect.
Is that the washing machine motor?
Yeah, so just so you know, the coils are at the bottom of the U.
That's
and
the
top is open.
Right.
So I didn't see her coil. Sorry, I was searching for the picture, so I just wanted to share that.
That's the Gerard one, right? That's the rotor on there has the north and 2 norths and 2 souths, 180, 180, and they're rotating over that high voltage coil, which is a very thin gauge on that coil and a lot of turns.
They're rotating over the actual steel plates right there. You see it grip it? You know what I mean?
The core, the iron core.
Yeah, they're going over the iron core.
But that coil's wrapped around that iron, so.
Yeah, you know what I'm saying.
Yeah. You need that core to pick up the magnetic field more efficiently. I mean, I doubt this thing would work without that iron core.
Well, I think that core is very important, yes. So that was it. I just want to share that in case you guys wanted to see it. So I'll stop sharing. So.
Well, I hate to break off early, you guys, but I got to finish writing my paper for tomorrow, and I'm trying to set up an experiment. So
now, come on now. Hey, get your computer right. Don't lose nothing.
No, actually, I got a backup computer, and I got 3 cameras, so I'm ready to go.
Well, I'm really excited. Before you leave, Gerald, stay tuned. I want to say that in 2 weeks, my liquid magnetohydrodynamics vortex of gallium is being replicated in a professional lab. So I'm going to have updates in 2 weeks.
Get out. Good for you, man. Damn straight. That's awesome. Right on.
Yeah,
one of the crew is getting up in there. That's I love that stuff. That's great.
That's so awesome, Phil. And when you're done with that gallium, feel free to ship a little bit out west to me.
Sure, we'll do, but in person. And
we'll have to all get together and meet. I'm telling you, we'll have a big barbecue.
Gallium Ormus.
We'll do what they used to do and go cow tipping. No, I'm kidding. I'm seriously kidding. All right, everybody. You guys have a great night, and we'll see you tomorrow. Good luck with that, Lulu.
Thank you.
Good night, Gerald.
All
Well,
right,
Joe,
thanks,
get
Gerald.
APEC tomorrow.
Darn
See you, Joe.
straight. Darn
See you, Joe.
straight.
Yeah.
Mike, you still with us? You want to go over some more
Yep.
of the battery?
Yeah. I don't know. What do you want me to talk about?
Well, just the setup that you've got going, the plans of it,
Yep.
and like, are you using it to connect into the motor system?
Not at this point. Right now, I'm trying to get the construction right. Like I said before, I'm having a hell of a time trying to outsource the graphite panels. But I can show you the little setup I got going right now.
Yeah. Hey, Mike.
Yeah.
Mike, if you can get to TRL3, the readiness level 3 of your experiment, you could join a conference that connects with the defense industry in the United States.
Hey, this is about free energy, not military contracting, Phil.
Yeah, but he wants to commercialize it, man.
To the military, it'll never see the light of day.
Mike, one day I'd like to get into it with you on switching tech. Advanced switching methods.
So that's it there. Got the light running. It's been running for 4 days. My last setup I had running for over 4 months. So I've changed, some of the chemistry inside and all that. But that stuff right now is kind of non-disclosure right now because I'm working with a partner on it. So, but basically, if you look at some of my old videos, they'll kind of give you an idea of the construction.
So what's that little light doing there?
It's basically just pulsing the power that's going in the cell. Now, if I were to take that off, that light or the load, the battery will go to sleep. The power will actually go down, the current will go down, it'll actually go into a dormant state. The second you put a load on it, the battery comes alive. So it starts pumping power. Yeah, it's kind of a very unique thing about the cell. So if you don't use it, it goes to sleep. Which
So
obviously,
are the two plates there I see on the bottom? Is that where you wanted the graphite?
yeah. These are the graphite plates. I actually have a sample of the graphite itself. This is the stuff they use in nuclear reactors to actually cool the actual reactor core down. So it's a very, very high grade of graphite. It is pretty light stuff.
What happens when you remove the load? Does the voltage slightly increase?
No, everything goes down. It goes to sleep.
It goes down. Huh, that's so weird.
It goes down. It goes to sleep.
That's hard to believe. That's so weird.
Yep. As soon as it doesn't act like a traditional battery. So it's not even a battery. It's actually a power plant. It's a reaction inside. So as soon as you put a load on it, it starts pulling the current, and then it's like almost like a heartbeat. It just starts pumping away, and it starts.
It's alive.
Yeah, it's alive. So this is the great graphite. Now the problem is this is what's holding me back. I have to be able to get graphite that's within 1/8 of an inch to a 1/4 inch thick, 12 by 12. Problem is the regular retail market doesn't have this. It's the problem. So I'm trying some experiments on actually laminating plastic with graphite. So I've got the graphite that's right here. This is the pure graphite. And this is what I'll use. But this is the actual pure graphite. That's what this is here. So I want to laminate this on plastic. So I'll be trying that this week.
So you just basically need a layer of it. Does it have to have any thing on top of it or anything?
The Well, that's part of the bonding process. I've got an adhesive that actually is semiconductive. So I could actually go layer by layer on a piece of plastic and fabricate it, basically. And then you have to heat it up and you have to heat it up and press it, and then eventually you'll get something like this. So that's what I'm gonna try to do because it's the easiest way and cheapest way to do it. Now, if I were to buy this, say, online, this size here, I'm looking at big bucks. I'm looking like $60 to $100 for something this size. So that's the biggest drawback right now. So I'm trying to come up with a method that I could actually manufacture my own plates. So that's where I'm at with the cell.
You're using those
Awesome, brother.
use those plates to cool it down. You said, or to or they're part of the generation of power. Okay.
Sorry, say that again, Mike.
Those plates are for generating the power, not to cool it down.
No, these were used in nuclear reactors. This is what they use in nuclear reactor cores to actually cool them down. It's thermoconductive, so it will attract the heat off the core, go through this, and then the heavy water goes through a core system and cools the reactor down. But this is the material that they use. So
You're trying to replicate that on your own, you're saying?
Exactly. Yeah.
Does it melt and pour just like regular metal?
When they bond this stuff together, as far as I know, they heat it up to about 3,000 C.
Okay.
And they also put it under heavy pressure. So probably about a couple of tons of pressure. And that's what forms this. So they would heat it up and pressurize it for probably, I believe it's over 2 hours at a high pressure, high temperature. So it's not an easy process. You need, big industrial machine to do that. But I'm trying to come up with the homebrew method.
Well, the pressure is the easy part. You just need a automotive part in order to take in and out the they're not bearings, they're little sleeves with the not gaskets, the rubber in them.
Right.
I forget what that's called, but you need one of those, and then you can build plates on it and create the pressure between it. And
yeah, I've got an idea right now that actually will work. It's just a matter of getting it. It's about $260 for the unit, and I'll be able to press my own plates. So I got to do some testing this week with the building method. Like this thing right now, like to make the cell is really not that hard, provided that you have a good building method, and that's what I'm trying to perfect right now. That's economical and performs up to what you want. So that's half the battle right there. So you can see I got all my elements and I got loads of stuff. That's a 5 kilo bag of silicon carbide. Yeah, and it's funny too. A lot of the material that I need for this project, I found at the pottery shop, where you get your pottery supplies.
Yeah.
98% of the elements I'm using are from the pottery supply store.
So
nice. Cool. Good sourcing, right? And that's the hardest part of it.
Well, that's it. Because the world we live in now, it's getting harder and harder to get stuff out of China, especially like specific stuff, right? And and cost is another thing, right? Everything's gone through the roof in price.
Oh yeah.
And then you got your import duty taxes and all that stuff. It gets costly, right? So most people don't want to do all that. They just go directly to a distributor. But the product's probably been marked up 2 or 3 times, and then now you're paying full retail, which is for a 12 by 12 quarter-inch plate, you're looking at $250. So I got to find a different way, a cheaper way.
There's nothing in North America.
No.
Mike's
No
on a
big.
mission.
That's why you gotta create the way so you can be that source and take over the market.
See,
That's the way
there, there are manufacturers that actually make the graphite. Actually, there's one just about 100 kilometers away from where I live, the actual miner. But you cannot purchase off them. You have to go through the distributors. You
Didn't
cannot
Berdini
buy
say he was
direct.
getting graphite from batteries? He was saving old batteries,
Yeah,
taking the graphite out
yeah,
of there.
but it's a totally different
You don't want to mess with
dimensions of
that, though.
what I'm actually. Well, it's not even that. They're way too small to begin
Not
with,
enough, huh?
right? And
Oh, the surface area is not large enough. They're too small.
yeah,
Plates. I
well,
got you.
that's
They
the
don't
key
make
to this whole
big,
thing.
huge alkaline batteries. They don't have big ones like somewhere.
Nope.
Sorry, I just gotta run outside quickly to do up my windows. A giant thunderstorm is moving in, so I will be back in 2 minutes.
Those old flashlights have those big
No
square
problem.
alkaline batteries in them.
Yeah, no, I need something that's 12 by 12. 1 foot
One
cube,
piece
right?
of
Yeah,
carbon
and
graphite.
I need 2 of them per cell, right? So very, very.
Right now, because they haven't figured out another way to do it other than melting.
I think I found a new method of actually fabricating a plastic plate. So I can buy the plastic for very cheap, and I've come up with a way of fabricating the graphite onto the plate. So that might be my ticket to building a cell very economically.
Hold on, you're putting them on plastic plates?
Yeah, no, because thickness is not important here. It's all about having just the layer.
Surface area. It's the surface area.
The
Well,
layer.
it's not that. I'm trying to understand because you can use resin to put things in. You can, what I mean? You can add it to plastics in a 3D printer. You can do a lot of different things. So I'm trying to figure
That's
out
an idea.
where you're going.
Yeah.
That's an idea.
I have a 3D printer.
3D printing carbon fiber. You can't use.
Yeah, I have that. I already have it. But the problem is the grade that they have presently is not. It's not. The resistance is too high.
It's not graphene. You're not looking for graphene here. You're looking for graphite, right?
Pure graphite.
Pure, 100% pure graphite, which is a different story.
Exactly.
That's why I'm asking. What's the plastic got to do? I didn't understand.
The plastics just the plastics just a structure, and basically I'm going to fabricate the graphite on top of the plastic. So the plastic is just going to create that surface area.
So pencil graphite's not good enough for this.
No,
you can have a graphite
too little.
It's not pure.
It's
not pure. It's not pure enough. I meant to say.
Yeah, it's not pure enough, and it's way too little. You need 1 billion of them to make a plate. So I could buy it in the bottles. They're about $45, and I could probably fabricate 2 to 4 plates with that graphite. Probably more, because the layers I'm going to do are very thin. Well, the graphite I have is 600 mesh, right? So
Hold on. What was Phil saying? He was saying something about it.
Yeah, go ahead.
You can have a graph alloy also.
They're trying to find ways to make graphene, but it's not durable.
I thought it was one of the materials, graphite. It's like stronger than steel.
I mean, you could use graphene also, but it's more expensive than graphite. You can use pure graphite.
Because it's
get the same
right.
result.
But graphene in its actual structure is at the nanoscale. I'm way bigger than the nanoscale, so I'm creating a conductive plate. Where I get the gains in the cell is in the square in the area, the surface area.
Okay. You have to take a bunch of pencil lead and heat it up to like 3,000 degrees.
No, I already got the graphite. I already got the graphite. That's not an issue. It's making it into a plate form.
Plate.
So
you don't know what, epoxy, nothing like that can work, right?
No, I found an adhesive that's conductive.
Conductive.
And conductive adhesive. So I would spray on a conductive adhesive onto the plastic plate, and then do nano layers at a time. Probably I would have to do 5 to 6 layers of this, heat them up, set it, heat it up, set it.
Scotch tape.
It would no. Why would I need Scotch tape?
Like the tape is drop the powder right on there.
No, it has to be on a hard surface. It has to be on a plate.
You don't want to roll it up, huh? Or
no, that's totally defeating the purpose of the whole cell. The whole cell is based on surface area in a flat linear plane.
So you can
The
increase
worst
voltage,
way,
right?
Oh yeah, my cells put over. Well, I had one cell actually pumping over 2 amps at 1.5 volt, 1.7 volts. A buddy of mine did a test in his lab.
Are you
He
shooting
was
for like a
getting
bigger, wider plate? Is that what you're going for?
exactly
Hey,
12 by 12.
Mike, if you use a positive and negative mold in a wax paper, then you can put the glue in there as a mixture and press it, and then it'll stay
Yeah.
as flat as you could possibly get it to get it there.
Like an
Yeah,
injection mold?
and yeah, it's going to be like well, I found a device that I could actually use that's on the commercial market. It's about $300. It's basically it's a t-shirt presser where you can do t-shirts on, and they make them 12 by 12, so I could actually heat up and press at the same time the plates after I put the layer of graphite. So that's how I'm going to laminate this stuff onto the plastic.
That's
It has a
thinking
heater,
smart.
so- Yep. Yeah, it's only
But you
$300.
You could also use an injection mold. I mean, they're only
Yeah, that gets really expensive. That gets super expensive.
really. I thought they were
Anything
like
like
just a
that.
couple $100.
Yeah, but you need one that's available for one. Number two, that's going to meet the requirements that I need.
Oh,
The
you
t-shirt
want something big, right? These injection molds are
Well,
expensive.
the largest cell I'm going to make is 12 by 12. I might even make some cells 8 by 8 and 6 by 6. It all depends on the application I'm using it for. Right? So if I want to power a house, I have to make my plates 12 by 12.
Polycarbonate,
So the
thin sheets of polycarbonate.
Yeah, probably 1/8 to a quarter-inch thick, and then
They make them 1/32. You kidding me? They make them real thin.
I no, it has to be rigid. It has to be
they're like $8 a
non-bendable.
piece though. It's
Yeah,
rigid. I bought one. They're pretty firm at 1/8.
Yeah,
1/32.
Yeah, I'd probably go 1/8, maybe even a quarter-inch, because they have to be super rigid, hard.
You take up a lot of space with that kind of thickness, and it'll weigh a lot.
Not really. The polycarbonate's pretty light stuff. The whole plate itself, like the actual core material that I put in between, is only going to be about within 2 to 4 millimeters thick. It's very, very close. That also helps with the amount of current. Closer the plates are together, the anode and cathode, the higher your current. I did tests. I was actually hitting 17 amps.
The plates aren't insulated.
What's that?
You don't have the plates insulated from each other?
Well, the stuff goes in the middle of it. So you got your concoction in the middle. You have 2 plates. One's the anode, one's the cathode. And I was able to get 17 amp pulses. So putting a huge amount of amps at about 1.7 volts. So it's pretty impressive. Now, if you get 18 of them lined up, you got a hell of a lot of power there. And that could charge
I
huge
think
battery beams.
the amp stays the same in theories, though. It doesn't change. What changes is the volts. Still going to have the same amount of amps.
Well, the thing is,
but the watts,
the
watts goes up with the volts. The amps don't change.
Right. Yeah. So calculate.
So you're going to get more power in the end.
Right. So it's also strength in numbers too. So say my cell puts out 1.7 volts at say 2 amps. Okay. Times that by say 10 plates. Well, 2 times 10
it's still 2 amps, but you got the volts going up. So you multiply the same 2 amps times that new
Exactly.
voltage. So there's your
And
watt.
because of for that reason, that's why they'll last so long.
I see him, Bernie.
That's
Guys,
nice,
he's
Bernie.
showing you the.
That's
I'll show the ice
interesting.
again.
Sorry, they're just melting pretty quick. So
That's from
But,
the GANs doing that.
yeah, the colloidal waters and how they create the exclusion zones of the bubbles.
That's so
crazy.
cool.
There's some kind of scalar waves passing through the GANs material, huh?
Right? So, Mike, if you're still doing your structured water, you should try freezing some of it and see if it does the same sort of thing. Sorry to interrupt you. Let you finish.
Yeah, as long as all you have to do is have a rotating magnetic field around a glass of water in, say, a freezer, you will get a vortex pattern. Water is ferromagnetic.
What kind of metals are you using, Bernie?
So it's just the gold and silver colloidal water from the purple gold silver, and I just pour the top of it into the regular ice trays, and then it does that.
You know, gold is like the positive, and silver is like the lesser positive. It's the negative. Sun and moon. You get flow to the two. You know,
I'm just gonna scoot up for a quick cigarette. I'll be right back.
If you had just one metal in there, what happens when you have just one metal? No,
it's the same. I started with like just a straight zinc monoatomic or straight silver, when it's in the white form and state, and it does the exact same stuff. Or sometimes it will do completely clear, or it will do like almost like a lightning bolt with the bubbles shooting down. Three different formations. That
is the process slower with a single metal, and is it faster with differential metals?
No, it's all the same, and it's like that. With the ones that were in this, I produced the gold and silver separately. It was silver on silver anode, cathode, and silver or gold and gold cathode, anode. For those reactions, then combined them together and then left it out in the sun and the moon, and that is when it's turned purple, and that you can still see some of the nano gold collected at the very bottom in the still solid state.
So it takes the same amount of time with one metal as it does with two different metals.
Yes, sir. And so it's like it'll happen very quickly with AC, just with the 5 volts. Like the first hour is all you can really harvest when it's making the white monoatomic. After that, it starts, it oxidizes and goes blue from there and becomes toxic. So at that point, you would be wasting your gold or silver or whatever metal you're using. And another way, though, is just connecting the two pieces of metal, your 2 pieces of gold, your 2 pieces of silver, or whatever metals you're using, with copper wires, creating a little circuit. And it'll, instead of hours, then you're going to be waiting days. But it's like for the first 3 days, it'll make the white monoatomic, and then after that, it'll begin to oxidize, sort of thing. But still produces it, collects it with none.
It's interesting how the monoatomics comes out the bottom of the open ends of the circuit.
Yes, only off the anode side. The cathode side produces all the hydrogen off of it. I got the zinc reaction in this one jar.
Right. You're right. Only on one
flows
side. Right.
off the anode, and it forms into like nanotubes and stuff. It's pretty crazy.
Yeah. It's only on the zinc side, but the graphene or the carbon side doesn't have anything happening.
Oh, I guess I just disturbed it. It hasn't built the tubes, but it's coming off the anode there. And then collecting there as a cloud. That one has crazy amount of hydrogen being produced. I don't know if the camera's capturing or not.
And that's copper coil in there?
Yeah, those are the triple copper solenoid coils.
You're not drinking that, are you?
God, no.
Thank God. Don't drink anything that has copper in it, Bernie. Come on.
Easy way to kill yourself. Like, no, thank you. Like,
I
you can't
think
even
silver, maybe.
handling it with clear skin. You're risking absorbing it and getting heavy metal poisoning quite quickly, right? So
Copper,
it's like,
you think it's because copper is not a pure metal? Is that what it is?
well, I'm sure it would probably
I mean, you'd have
be
to
just
use
as
pure copper
reactive
to
with
do it,
like
you know?
silver gold coils as well, right? It's just increasing the surface space and the field of it.
Copper is generally toxic to human health.
It's just
so
into your
Well,
brain.
especially when it's oxidized. But I actually have the first few years, I was just drinking silver, copper, zinc, all in the white form.
You're better
Never
off
in the
with
blue
the
oxidized.
zinc. The zinc saved your ass. If you didn't have that zinc, that copper would have screwed you up, man.
Hmm?
Yeah,
Good thing
trust
I
me.
didn't.
Listen, I was taking zinc and copper
I
supplements.
know a lot. Now
regardless.
I just do the gold and silver with a little bit of
Don't
zinc.
do any of the copper. The zinc is good. That's the best thing is the zinc.
Bicycle brakes, like the
Gold or zinc, you know.
it has graphite in it, large amounts. So if like you need graphite, like in good size, bicycle brakes. That's what it's saying that they use it. Yeah.
So yes, to answer this question, colloidal silver does oxidize. It's like when it's in the blue oxidized state like this, then it will produce oxidized colloidals, which is then a disinfectant, but you'd never drink that. That's how people literally turn into the Smurfs and then die of heavy metal poisoning. And so you never want to ingest any of the water or any of the materials that is blue and oxidized, because it is just straight poison. I've only ever experimented with the white and the purple, and I try it on the plants first to make sure that I'm not that if they do well, then hopefully I do well with it, right?
Have you seen the yellow silver water?
Yeah. Oh yeah. I make the yellow too. When you put a double negative and cut the positive of the reaction in electrolysis, whether it's blue oxidized or white monatomic, it instantly all turns yellow into what the alchemists call the sulfur state. And then it also can turn red, which then I believe is hydroxide, which is also toxic.
So yellow's toxic too?
I suspect so. I have yet to actually test the colloidal waters on plants yet, but I've got a bunch of the sulfur state diatomics or nanomaterial.
I used to drink the yellow stuff.
No, never drinking that shit either. Like,
well, I'm still here.
But they're used for like antibacterial, antiviral, like spray and stuff like that. But I won't even touch the material without gloves, because you risk absorbing it and instantly a huge level of heavy metal accumulation within your cells, right? It's
from the yellow colloidal silver.
Well, from any of whether it's blue, red, yellow, black,
right,
white,
generally
whatever,
you want it to be clear.
It's nanomaterial, so it absorbs into your skin, just like when you drink it, it absorbs in quickly, right? So that's why it's like you have to really know what you're doing, or you will kill yourself very quickly. Or if you use it properly and apply it to the right things, you can disinfect stuff, disinfect wounds, stuff like that, and then use the healing water properties.
I used to use liquid carbohydrate drops. It's basically carbon would turn it yellow.
Right, it's like I really need to get into the mass spectroscopy to actually see what the heck these different chemical compounds are, the different oxides, hydroxides, if it actually is a sulfide that forms out of nowhere from the water, which would be a transmutation. The ancients called the red state the mercury state. So it's like, does it also create mercury oxide, or is it just more hydrogen, hydroxide more likely? And yeah, a lot to it, but a real science of electrochemistry.
Do these things actually still work like metals? Like if you put a magnet near them, does it do anything?
No, it does the exact like it strips a lot of the magnetic properties like iron ferrite. Like I hold the magnet up to it, loses all magnetic attraction and stuff. Like it's interesting stuff.
Zinc and
Lots more
copper
tests to do.
antagonize each other. They oppose each other. Zinc and copper.
I've definitely discovered and invented a few different types of electrolysis methods, but I've got a lot more that I theorize to like tone down, just don't have the equipment to get it done yet. I guess we got like 5-10 minutes left. Any last discussions or words?
Yep. Yeah, I gotta get to bed early tonight. I got a camping trip tomorrow, so we got our civic long weekend here. So it's a long weekend.
Some sniper is
away.
You got a red dot.
Oh, snap. See, this, Phil, is why we do not want to apply for these military things like that.
Is that coming through your front window?
Yeah, like this, however, hydrogen production is too dangerous. It's like, no, it's not. I've like literally have jars of freaking nonstop hydrogen production bubbling away, several of them in a row for like years at a time. Can hold a lighter up to it? It's like it'll burn a little bit, but like it doesn't fill the room and explode or anything like that. It's a giant misconception, and yeah, they want you to think that so you don't pull a Stan Myers. And well, I'm developing it, but I'm not. You can't go too much, or they'll Stan Myers you, right? I can show you this. You can show you like that it's making it, but there's only so much without risking.
You can graphene sheets from old cell phones. I'm reading about it right here in this book. You can actually like get those behind the screen. There are thin sheets of graphene that you can make old cell phones.
Yeah, see, that's at a nano scale. I'm working way bigger than that. I'm working at about 600 mesh.
Okay.
So that's a pretty fine powder, and that's the one I showed you in the bottle there. So that's the grade of graphite that you can get in plates, but I have to come up with a new way of making the plates big enough. So there is a plastics manufacturer in the town not too far from where I live. I'm probably going to have to go down there and see what kind of plastics they have available that I could actually have cut and holes drilled in them, because there's going to be actual screws going through it to hold the two plates together. And I got some spacers that I'll have to print up on the 3D printer and come up with a very effective fabrication process. And that's what Michael Kantz, I think, before he passed away, actually perfected. And unfortunate, he passed away. So all the patents, patent pending that he did have, basically all the work's been lost. I haven't been able. So whatever literature he did have out there, I've been studying, and it turns out a lot of the stuff he was writing was very cryptic. So certain things he was saying, there was a meaning behind it. You have to decode what he was saying. So I've decoded a lot of what he said, and now I'm starting to figure out exactly how he built those plates, to the point where I got a pretty good idea of what elements he was using inside. So I'm not going to talk about that because right now I'm under kind of a non-disclosure with my partner on this. The science is pretty easy to understand how it works. It's what's inside that counts. Right?
Yeah, how you make it.
Yeah. So I don't even like to call them a battery. They're not even a battery. They're actually a solid state power plant, because they don't store power like a traditional galvanic battery does. Not even like a lithium either. So if you actually were to try to charge these things, you'd actually damage them. So As soon as you put it together, they're on. There is no off switch. They run continuously. If there's no load on it, they go to sleep. You put a load on it, it comes back to life. So they're very, very unique.
I have a quick announcement before we end the stream.
Yep.
So I have a premiere happening tomorrow at 8 p.m. Eastern Standard Time. It is a new Divine Science special on a real-life flux capacitor, and I think you all will really enjoy it. It's about 60 minutes long, and it's in 4K. So I'll be I already sent out emails, but Nawal, if you send me your email, I'll send you an invite to the premiere as well.
Okay, I will do that after the show.
Yeah, just use the mailing list that.
Bernie,
and...
yeah, I'll have to do that. I'll check it out. Yeah, because I was looking for her email and I couldn't find it. Maybe I overlooked it.
I could put it in the comment if you'd like. In the chat, like the
private chat there.
Yeah.
Well, private chat is just us, right?
Exactly.
Yeah.
Well,
all right.
Good, everybody. So I guess we'll square it up, Bernie. I'd like to thank
I'll just play this little outro, and we'll see everyone tomorrow during APEC. And until then,
yep.
Viva la
and then
free energy.
Have a good
night.
night.
And I'll be going live. Yeah, I'll be going.
Remember, if you like my content, please consider subscribing and hitting the like button on my videos. Comments and any form of engagement dramatically help us break through the YouTube algorithm. I also have a website with research on the Thunderstorm engine, plasmoid technology, and do-it-yourself guides for Malcolm Bendel's retrofit, courtesy of Jordan from Alchemical Science and the Martin Fleischmann Memorial Project. Check out my store for exclusive merchandise along with our forum, where you can post questions, share videos, and join in the community to help destigmatize all forms of forbidden knowledge. Don't forget to check out Jordan's channel Alchemical Science and Bob Greenier from the Martin Fleischmann Memorial Project YouTube channel. They're on the cutting edge of cold fusion technology. More updates on that coming soon. Stay tuned for a new episode of The Social Situation, where I take you on a deep dive into the corrupt world of America.